Right, hi everyone. I'm Dorian from the AI for Health team, and I'm gonna introduce you a little bit into our project and what we're doing. And yeah, to start off, we're improving the automatic lung segmentation from X-ray images. I will explain a little bit further of what that means exactly. But first, a introduction. We're with 5 team members. First off, Jari Immerzeel. He studies at the Radboud in Nijmegen and he studies AI. Then there's me. I'm a data science student in Tilburg. We have Meert van der Berg. She is a medical engineering student in Eindhoven. Jans van der Zande and Meert Kater, and they're also both data science students in Tilburg. And yeah, Bram doesn't need any introduction. Everybody probably already knows him, but he leads us and he makes sure everything will yeah goes in track. All right, so what have we been up to? Well, until 2 weeks ago, we had a bit of a rough start. This was due to that we were promised to get data from Mastro, but the data wasn't delivered or didn't arrive for us. So we had a little bit of project change, but now we're up and running and we're at full speed. So what are we doing? We are trying to build a generative adversarial model that accurately segments X-rays. And what does that mean? Okay, so we have a huge data set of 1,000 chest X-rays, and they all look a little bit like this. And the idea is that with our generative model, we are able to generate the masks for these images. And now maybe some of you think, well, why is that needed? If there are people here who also attended the masterclass Pitfalls for Machine Learning, then you already know. But the reason why is because when you want to train a model to classify whether it's COVID or apnea or any other lung disease within the lungs, then you have to consider that you only look inside the lungs. So yeah, how they call it in the masterclass, there is a signal and noise. And for us, the signal is everything that is inside the lungs and the noise is everything around it. So to be able to train a model to classify anything, we need to concentrate only on what is the signal in this image. That's why it's needed to accurately segmentate images. Why are we doing this? Well, there was a question from Mastro, the Maastricht UMC. They want to train their model on a bigger data set, but they don't want to manually draw in all the masks. So they asked us if we are able to make a model that generates these masks automatically so that their model is able to classify and detect COVID and hospitalized patients. This is all in order to increase workflow. This is a little bit how a hospital workflow looks right now. A patient enters a hospital. They are transferred to radiology to make a chest X-ray. Then a radiologist has to tell if it's suspicious or not. Then they go through a CT scan. Another radiologist has to comment on it, and then we get a result. Well, these steps for the radiologist can be automated, or we want to know if they can be automated. So they asked us to help for this step, for the classification part, or not. We do the step before the classification part, where we provide the model that does the classifying with the right input data. A little bit more on the generative adversarial model, because I can imagine that not everyone is already a specialist on this field. Well, the idea is that you actually have 2 models in your network, and it consists of a generator model and a discriminator model. And they they are in a sort of game with each other, and it goes as follows. The generator receives an input vector. From this input vector, it generates a mask, and this mask will be evaluated by the discriminator, and the discriminator classifies it as real or fake. Then it puts back this information through a loss function. But the idea is that first you train your generator that it is able to fool the discriminator in a way that the images start looking more and more like real examples. And after the discriminator can't tell the difference anymore between real and generated, we switch off the generator for a second, and then we go back and train the discriminator again. So the discriminator gets better at classifying real and fake. So now the discriminator is in an advantage, and we turn on the generator again. And in this way, in this cycle, the images that are going to be generated will become more and more like the real examples, as you see in this picture. I hope this is a bit clear for everyone. So where are we now? Where are we standing in this project? We just finished the first sprint. We've been working on this for 2 weeks. This consisted of a bit of manually drawing masks because our data set didn't provide enough COVID positive images with masks. So we thought it was a good idea to expand on that. We also did a lot of pre-processing, like standardizing and resizing images. So our model will be good to go. And our total data set now is consisting of 4 open source data sets with a total now of 992 images, so close to 1,000. And the next couple of weeks will be us training the model, evaluating the model, and providing Masto with our code and manual, and hoping that our solution for this problem and our model will be usable in practice. All right, so that was the presentation in short. Are there any questions?
I don't have any questions, but I just want to say that projects looks good and the progress looks amazing. And I just, even with the bumps you had at the beginning, you still put out something the hospital will be proud of, I believe.
Thank you.
Yeah, I also really, I think it's really nice to have these kind of presentations, because I think everyone has a vague idea of what you guys are doing, but I think it's really nice if everybody has a real understanding of what's going on within our team. So yeah, thank you very much. You've cleared my my vagueness about it up. Yeah, indeed. Does anybody else have a question? Because nobody is really asking something, but you can still.
I have a question.
Yeah.
I'm just curious about what the generator model produces. So when you have some kind of error score that tells you how easy it is to discriminate from a real X-ray of lungs, can you tell just subjectively looking at the images whether it's good or not?
So we are not actually generating the X-ray images, we're just generating the masks. So, and yeah, I think you can pretty well, it is pretty good to see for us, for human being, if they're looking like real masks or not. But for our model, it will be a bit trickier. We yet have to find out how this will go in progress, because I think this week or next week will we get to the point where we're actually gonna train our model. So yeah, I wish I had a better answer for you now, but I don't, not yet.
That's okay. It's early stages.